All right, now what we're going to do, we're going to be given a lens and an object, and we're going to try to figure out where the image is located. And we're going to do it two ways. The first way we're going to do it is it's called ray tracing. You draw pictures or lines on graph paper. And then after we learn how to do that, we're going to do it mathematically. So if you're really smart, you'll do it both ways, because then then you're guaranteed to get it right because you can check yourself. So this is called, all right, so ray tracing. All right, what kind of lens is this, right? This is a lens. You see the glass lens? So what kind of lens is that? And where's the focal point? Well, you can see that the parallel rays, right, because we're assuming the object's far enough away so that we can have parallel rays coming in, and the parallel rays converge to a point. So it's called a converging lens, all right, converging lens, and this is the focal point. So the rays actually converge or intersect at that point. Again, real light will always have a solid line, all right? When we don't have real light, when we have like the projection or something like that, then it's dotted line. You'll see, don't worry. Okay, here, perfect example. Okay, what kind of lens is that? So now, you have the light coming in, and it doesn't converge, it diverges, right? It goes away. So we're going to call that a diverging lens. And there's other names for it, but whatever. Okay, so, and again, here's the important thing. So these are the outgoing rays, right? The outgoing rays. Well, how do you find a focal point? They're certainly not going to converge, right? So you just backtrack. So you just backtrack on these outgoing rays, and that's the focal point. So this is not real light, right? This is the real light. Here we just backtracked. So that's called the focal point. All right, so rays appear to diverge from this point. Yeah. All right, so what we're going to do, so here's a typical problem. So when you buy a lens, you specify the focal length. That's what you do, And so we're going to have a particular kind of lens where you know the focal length usually, and you usually know where the object is, and so what you're interested in finding is where the image is. So that's the typical problem. Not always, but that's your typical problem. Not only do you want to know where the image is, you also want to know if the image is upright or inverted, and if it's magnified or not. All right, so this is the key to drawing these ray tracing diagrams. All right, first of all, converging lenses always have positive focal lengths. That's crucial. Okay, so in order to figure out the image, you draw these three lines, and you get it right. I mean, it's as simple as that. And you really want to remember this because you're going to use something similar for diverging and for mirrors, and it's really important. So here's the first one. So here's the object. So you just, you usually draw the object up, or it's called upright. So you just draw your object. So the first line or ray you want to draw, so you go parallel in, right? So parallel to the lens, and then out through the focal length. So I just always call that parallel in, focal out. We're going to see it again, all right? Parallel in, focal out. The second one, you go through the focal length first, then parallel out. So this was parallel in, focal out. This is focal in, parallel out. So that's easy to remember, right? The third one is the best. You just go to the top of the object, you go through the center of the lens, and just keep it straight. Now, the image is going to be where these outgoing rays intersect. Now, you know as well as I do, you only need two rays to intersect to find the image, right? But I would recommend you always draw three, because then it's a check, right? The third ray is a check to make sure you didn't goof up. All right, so again, parallel in, focal in, parallel out, just straight through the center of the lens. That's all you need to do. So we want to remember that. Okay, all right, let's see. And again, please download some graph paper. If you don't have graph paper, your results are going to stink. They're going to be awful, all right? And I'm going to make you do this on the exams. So get some graph paper. Okay, so here's an example. I will do it. I don't have graph paper. right? What can I say? There's a few classrooms on campus that actually have they have graph paper on the whiteboard, but not here. Now, I should warn you, one of the biggest hassles of drawing these ray tracings is, you got to scale everything. And, before you do it, you don't really know, if you're going to need a lot of space on the right or the left or whatnot. And so it's kind of a pain, I admit it, but you just got to deal with it. So I've already drawn these, so I can sort of cheat, right? Okay, so this is what you do. You draw this, okay? And again, like I just said this, I'm repeating myself. You don't know where the object is going to be. And so it might be over here, it might be over here, So, so you have your piece of paper, and it might extend past your piece of paper, so you have to erase it and do it over again and rescale it, and that's life. Okay, so let's do it. So first thing you always want to do is you want to draw your optical axis, just that, whatever. This. Okay, then you got to figure out then you put your lens somewhere. And again, I already did this, so I know if I put my lens here, I'll have enough room on the whiteboard for everything. So just draw your lens. What I do, you don't have to, but if it's converging, I do that. If it's diverging, I would do this. But who cares? Well, I mean, actually, it's nice to do that because then, if it's a diverging lens, it has a negative focal length. And so it'll help remind you of that. Okay, let's see. Now we got to scale. All right, so this is perfect. Ha! What do you know? So I'm just going to do, all right, so the object is at 25 centimeters, which is right there. The focal length is 10, which is right there. So I got to get focal length on each side. All right, so this is a scale drawing. With graph paper, you're going to probably want to say like so many blocks equals a centimeter or something like that. But you got to make it a scale drawing along this way. Now notice they didn't tell us the height, so you can just draw that however you want. But generally speaking, you want to kind of draw it high or somewhat high, just so you can see what's going on. So let's see, did I do that? Yeah. All right, so I'm just going to make some. All right, so let's label it. So there's a focal point. That's a focal point. That's your object. So that's S. What we want to find is the image. Okay. Here we go. Ray number 1. And again, come on, I don't have graph paper, so I don't know if I'm going to make these things perfectly parallel and everything. So first one, parallel in, and then focal point out. Whatever. So there's my outgoing ray. The second one, focal point in, focal point in, all the way to the lens, and then parallel out. Let me make this longer. And then parallel out. Okay, so actually, I'm done, right? I know that this is the outgoing ray, that's outgoing ray. The intersection of these outgoing rays is where the image is, so it's right there. But, it doesn't hurt to do the third one, except it's going to hurt because I don't have a long enough ruler. So the third one just goes straight through the center of the lens. Whatever. It's supposed to be a perfect intersection there. Obviously it's not. All right, and then here, this is the image. So that's the image. So this distance here, right? So S is that distance, right? And this is S prime. So S prime is that distance. Okay? So there you go. That's how you do it. Now, they're not all going to be that easy, right? They're going to be some that are more difficult. Now, there's a bunch of conventions which you have to learn. So let's talk about these conventions. Number one, this is real light, right? These are solid lines. I didn't have to backtrack or anything like that at all, you know? And so this is a real image. Real image. For a converging lens, the real image will always be on the opposite side as the object. All right. Number two, look at this was up, this is down. So this is called an inverted image. And the magnification, well, we started off with that and went like that, right? So it shrunk, right? Right, it shrunk. Okay. So, yeah, hold on. Yeah, okay, let's see. The magnification is negative if it's inverted. Let me talk more about that magnification. There's really two equations you can use for the magnification. All right, so this is actually graph paper. So I really did you can see I did a better job in the graph paper, right? Parallel in, focal out, focal in, parallel out, and just go straight through the center. See that nice intersection there? Okay, so this is H. H is the height, and this is the object, so there's no prime, right? This is H prime, it's the height of the image. Okay, so it's a real image because it was made by real light rays, and it's inverted because that was a up and that was a down, right? All right. And you can see I had to figure out a scale and everything to make this work out nicely. Now there's two equations for magnification. So M stands for magnification. So M is equal to minus S prime over S. Okay, so minus, so there's a minus. S prime is 17, and then S is 25. So you get minus 0.68. So the minus tells you it's inverted. Now the other formula is just the magnitude of the magnification. So absolute value, right? So it's just H prime over H. So what that is, you just measure the length of this and you divide it by the length of that, right? And so that's the magnification, 0.675. So, not exact, but not bad, right? And you're never going to get it exact when you're drawing on a piece of graph paper, but that's pretty good. That's pretty good. All right. How do you learn how to do this? By doing it yourself. So everybody, I assume you have some graph paper because I will have sent you an email before you reach this point in the video. Grab your graph paper and drew the ray tracing for this problem. And find S prime and also find the magnification. So don't look on the video until you do it, all right? All right. Okay, so I assume that you've done it. So let's discuss it. Let me do it. See. All right, there's my lens, converging lens. All right. Okay, so the focal length is 5, so I guess I'm going to scale this again. So let's see. So there's 5 and there's 5. And then the distance from the lens to the object is 20. So I'll scale it right there. And they don't tell me the height or anything like that. No problem, I'll just make something up. There. All right, so there's S, focal, focal. And that's, all right, so now let's do it. Okay, once again, first one, parallel in, focal out. So outgoing ray right there. Next one, focal in, focal in, parallel out. Last one, just your check, just straight through. Oh, I did a pretty good job on that one. What do you know? Okay, so there's the outgoing ray, outgoing ray, outgoing ray intersects right there. So this is your image. All right, and now let's see, now I'd measure it. And I get about, I don't know, 6.8 or something like that. So S prime is about 6.8. How did I do when I did it last time? All right, so according to my 6.8, and it's supposed to be centimeters. Okay, so that's how you do it. And now let's find the magnification and all that. So there's my nice drawing. Hey, what do you know? No. All right, so the magnification minus S prime over S. If it's a real image, S prime is defined to be positive. If it were a virtual image over here, S prime would be defined to be negative. There's tables in the book that explain all this stuff. But I'll show you later. All right, so S prime is positive 6.8. So we have minus 6.8, and S was 20. So magnification is 0.34, and it's negative, which means it's inverted. Right, now we find the magnitude of the magnification, H prime. So we measure the length here. And then we divide that by the length here, and we get 0.325. So that's not bad, right? Just for drawing, you know, close enough for me. All right, now the last one that we're going to do is a tougher one. So these were all nice because the object was outside of the focal length. Well, the next one, the object's going to be inside the focal length, and you're going to have to do some thinking on that one. So let's do it. All right. So now we'll look at the focal length is 25 centimeters, but the object is only 10. So like I said, we're inside the focal length, right? We're in here now. And so what I would recommend for something crazy like this is draw this first. This is always an easy one, right? There's no thinking involved. You just draw it. And then either draw this one or this one. Okay, so you do it on your own. So pause your video and figure out how to do it. And you might struggle a little. That's all right. All right, let's do it. Good luck doing this one without graph paper. Well, you'll see. Okay, this is, yeah, okay. All right, so the focal length is 25. Okay, it'll be fine. Focal length is 25. So again, it's going to be scale drawing. You got to do it scale drawing or it's not going to work. 25 there, 25 there, so I got to extend it. Focal object is 10. And then I make it big or small, big or small. All right, so there it is. Okay, so that's that. Now let's do it. Okay, like I said, the easy one is just the number 3. right? Okay, now what you're going to do. Okay, well, let's do number 1, all right? So number 1 says parallel in, then focal out. All right, let's just do it. Parallel in, focal out. Okay, now notice, here's the thing. Remember, the image is formed by the intersection of these outgoing rays. Well, come on now. They don't intersect over here, right? So what are you going to do? You're going to backtrack. So you're going to just backtrack. And again, it's not real light, so that's why I use dotted lines. Okay, backtrack this one. All right. Okay, so there's the image right there. Now, just for fun, let's do focal in, parallel out. Now, how do you do focal in? Well, you do it like this. Focal in, right? So focal in, you just do it like this. So focal in, come on. Focal in. And parallel out. Okay. So again, so those, oh gosh. So remember, the image is at the intersection of these 3 outgoing rays. So you got to backtrack. So you backtrack. I didn't do such a great job on this one. Oh well. All right. Not bad. That's not bad. I'll take it back. So here's the image right there. So there is your image. All right? So that's a bit more challenging than the other 2. So, oh, I got to measure it, sorry. I got to measure it. So this is, I don't know, 16.25 or something, 16.3. So S prime is about 16.3 centimeters. But you got to use a sign convention. So look in the book, they have a table, and it gives you the signs of things. If the image is behind, in front of the lens, or in other words, if the object and the image are on the same side of the lens, you have to give this a negative. You have to, or else the formulas won't work. Okay? All right, so there it is. And look at what happened. It was magnified, right? The other 2 shrunk, right? But this was magnified. So let's plug it in. Let's see what we come up with. Okay, so there's my nicer picture. Not bad. Hey, what do you know? I didn't know that, honestly. That was just pure luck. All right, so this is virtual, agreed, because it's formed by not real light, because we backtrack. Or another way you can think of it, if the object and the image are on the same side of the lens, you know it's going to be a virtual image. So it's virtual, and it's upright. So it's the first time we've seen an upright image. Let's plug in the numbers. So the magnification equals minus S prime over S. And here's what I mean. You get to get these minus signs right. So S prime is minus 6.3. Minus 6.3. S is 10. So you have a minus, which makes a plus. So you get 1.63. And then here's the absolute value, right? You just measure the height of this divided by the height of this. And when I did that, I got like 1.7. So that's pretty good for drawing, you know. So again, this is the one, this is the tough one. Make sure you can do this. It's challenging. All right, so those were all converging lenses. Oh, by the way, keep these ray tracings because we're going to do the same 3 ray tracings with the equations later on. So keep them. All right, so these 3 examples were converging lenses. Focal length is positive. Now let's do some diverging. These are tougher. Well, not really, but a little bit. I don't know. Uh-oh. Oh, man. That's supposed to be a negative. I mean a less than. Oh, golly. All right, sorry. Diverging lens, f is less than 0. Gee, bad. That's what happens when you cut and paste and you're not careful. All right, so in order to draw the ray tracing, you just draw 3 rays again. And it's awesome. So look, parallel in, but now it's diverging, right? So it's not going to, can't go through this one because it's diverging, right? So parallel in, but then it's going to diverge. So how can it go through the focal length? You got to backtrack, right? So again, same thing though, right? Parallel in, focal out. Parallel in, diverge, focal out. Okay, this one, remember what we did. The second one before was focal in, parallel out. All right, so focal in, but wait a minute, it's going to diverge, right? So this is aimed at the focal length, focal point, right? But it diverges, so it's parallel. Got it? So this is a straight line, but then it diverges. So focal in, parallel out. And then thankfully we still have our good old friend, right? The good old ray number 3, you know? You can always count on it. All right, now you got to be careful about something. Sometimes the questions on the exam or the homework, they'll say, you have a diverging lens whose focal length's magnitude is 2.5 centimeters or something like that. If they say something like that, they're just saying what the magnitude of the focal length is. If it's a diverging lens, it's negative. So you got to put that negative sign in there. All right, so let's do it. Okay, so let's do this one. All right. I do that if it's diverging. It just tells my brain I'm expecting a negative focal length, you know. Okay, and let's see. 25 centimeters away, so here's my scale drawing. That's 25, focal length 10. Focal length is 10, so 10 and 10. So focal, and S. And let's see, do I want this big or small? Big. Big. And you're not going to know this until you do it. Sorry, that's kind of how it works. All right, so I'm going to make this bigger. Close enough. All right, there you go. All right, number 1, parallel in. Oh, I'm going to use a different color. Parallel in. Then it's going to diverge, but it's focal out. So here you go. Focal out. So it diverges, and you backtrack, and there. All right, so parallel in, diverges, so we backtrack, focal out. Let's do our friend. Nice easy one. Number 3 just goes through the center. All right. Okay, so look at, here's an outgoing ray, here's an outgoing, so we know the image is there, right? Well, let's do number 2 just for fun. Hopefully, close enough. All right, so number 2, you know, we're aiming at the focal length, right? So it's focal in, parallel out. So we're aiming at the focal length, but it hits the lens and then goes parallel. Hey, not bad. So there you have it. You have 3 outgoing rays. obviously they don't intersect out here. They intersect over here. So I got to backtrack this guy. And there you go, right? So this one, this one, this one, so right there. So there is the image. So that's S prime. I got to measure it. Like 7.25, whatever. S prime is like 7.25 centimeters. All right, now it's on the same side as the object, so you got to give it a minus sign. Okay, let's see how well I did. Okay, so when I did it on graph paper, I had minus 7.3. Good enough for me. And look at it shrunk big time, right? This is H, this is H prime, so it shrunk. All right, so it's a virtual image, right? Because it was caused not by real light. It was caused by, we had to backtrack. So it's virtual, it's upright. M minus S prime, so we have a minus minus, right, over the 25. Right? And so we get 0.29, and then we just actually measure them, right? Measure that, compare them, and you get 0.26. That's close enough for me. Okay, so there you go. So those are, most people consider those diverging lenses kind of challenging, but if you just remember, you know, parallel in, focal out, focal in, parallel out, number 3, you got it. But you got to practice, just like anything else. Okay. Let's see. Now what we want to do is we want to do the math. So let's quit. Quit.